Hi guys, Mr. Ward again. Unit 4, Day 4, more on exponential functions, growing and decaying. But we're going to look more at the equation and less at the graph today. And that's what we talked about, that A value, that B value, the B being greater than 1 or a whole number with growth, the B being a fraction or less than 1 meant decay. So we're going to give a couple terms to these A and B values. We're going to call A the initial value. Initial is a fancy word. I feel like I'm going to sneeze. Pardon me. Initial value is a fancy word. I'm going to call it starting value. We'll use initial, but it's also starting. Okay, the B, on the other hand, we're going to call the common ratio. Let's see how well I wrote. Let's see if it picks it up. Initial value, like it. Common ratio, like it. See if it gets started with the parentheses. It did. Very nice. All right. So now, we're going to name each piece, and then we're going to look at the B value. And again, if it's a whole number, it's going to mean growth. If it's a decimal number, it's going to mean decay. So the initial value is the one in front. So the first example, the initial value is 4,000. The common ratio is 0.6. Is B a decimal or a whole number? It's a decimal, so it's decay. Let's keep going. We're doing great. A, the initial value up front, 325. B, 1.8. Now it is a decimal, however, the decimal is bigger than 1, so that means it's going to be growth. You got it. Next example, 2.50 is A, B is 5, and B is definitely bigger than 1, 5, way bigger, so it's growth. And the last one, A, the initial value or starting value is 350. B is 0.25. That's a decimal smaller than 1. It's going to be decay, backwards, J, decreasing. All right. So the exponential function with the initial value A being positive is growing or increasing when B is bigger than 1, and it's decreasing when B is less than 1. What did we say? Bigger than 1 is a whole number, less than 1 is a decimal, except for that case where it was like 1.8, where that would be wrong. All right, let's keep going. Doing great. We have an equation that means something now. Trudy's looking at purchasing a car. And the car's value is determined by the function f of t or y equals 7,500 times 0.6t, where t is the number of years Trudy's had the vehicle and f is the value of the car at that time. And what happens to the value of cars over time? I'm sure you probably know, or you've heard your parents say, they go down. They're worth less over time because they get older, they get rusty, they break down. So this would actually, I'm pretty sure, will be a decreasing, decay. And the new word we said, appreciating means going up. Another D word, depreciating, is going down. All right, 3 D words. So, what's the purchase price? Well, I would say the purchase price is also the starting price or the initial value, which goes in front. Trudy bought the car for $7,500. Common ratio, on the other hand, is the number in the parentheses, the B value, 0.6. And because B is 0.6, it is depreciating. How do I know it? Because B is less than 1. It's a decimal. All right, very good, very good. We gave you that equation, this one here. We're going to talk about below. We have to figure out the equation. So what do we need? In order to write an equation in the form y equals, I'll use y instead of f of x, a times b to the x. You must have the a, which is the initial value, or starting value. I'll put in parentheses below it. How much the car is worth when we bought it. and the B, which is the common ratio. All right, so Dan puts $50 into an account that doubles every year. So how much did he first put into his account, his initial or starting value? That's right, A equals 50. And what does double mean? We've talked about that before this year. Double means times 2. And that right there is your common ratio. So it's 50, 2 to the x. We have our equation. Now we got to get a table. So we're going to go to our calculator. We're going to plug that in. Y equals, clear that old junk out, 50, parentheses, 2, parentheses, caret, x. We have some values we're going to ask. Now, a lot of these real life problems won't have negative x values because there is no such thing as a negative year. So we're going to start at 0. Second graph, we go down to 0. 0 is 50. And that makes sense because 0 is the starting time, and that's how much Dan put in his account. After 1 year, it doubled to 100. After 2 years, it doubled to 200. And after 3 years, it doubled. It wouldn't be 300 because it's 100 times 2, 200 times 2, which makes 400. And then we got to answer a couple questions. What was the initial amount in his account? What did we use for A? We said it was $50. The common ratio was times 2. And is it appreciating or depreciating? It's appreciating, going up. And you could say, table goes up. But we also can say B is greater than 1 because it's 2. All right, very good, excellent work. We got another one. A, initial value, and B, common ratio. And initial is also start. So what do we have? Sarah purchased a jet ski for $12,000. That sure sounds like the starting value. There's A right there. $12,000, parentheses. It's estimated to depreciate, go down in value, where B, the common ratio, is 0.9 annually. There's our common ratio, 0.9. Don't forget, to the x. So we have our equation. We can put it in our calculator. Y equals, clear out the old junk. Don't put in the commas. 12, 1, 2, 3 zeros, parentheses, 0.9, parentheses, to the x. We get that J graph. Table says we're going to start at year 0 and we're going to go all the way up to year 4. Second graph, start at year 0. $12,000, just what we expected. How much we bought it for. Year 1, it's worth $10,800. Year 2, it's worth $9,720. Year 3, it's worth $8,748. And year 4, it's all the way down to $7,873.20. If you want to put a 0 there, you can. All right, if we answer these questions, what was the initial cost of the jet ski? That's also the A value. We know that to be 12,000. What's the common ratio? That's the B value. We said was 0.9. Is it appreciating or depreciating? It's depreciating. Why? Because B is less than 1. 0.9 is less than 1. All right. Very good job, guys. That last example, we had to create the equation. Did a really good job with the A and the B value. Use these notes as examples. Work on your day 4 classwork. Very good. Have a great rest of your day. We'll see you.